Another topic sometimes that I see people have trouble with is the topic of literal equations. You might have some kind of a formula and you're asked to solve for a particular variable in that formula. And the thing that I really like about literal equations is you're really doing the same things you normally do to solve an equation. You're just using variable values instead of numbers, and sometimes variables are actually easier to work with than numbers. So for example, let's say that I wanted to solve this equation for b. Okay? I want an equation that says the base is equal to something in terms of the area and the height. Okay? A couple things here. First of all, you might want to get rid of the 1/2. Okay? So to get rid of the 1/2, remember that you can multiply something by 2. It's an equation though, so I have to multiply the other side by 2 as well. So I'm going to get 2a equals, and then this will just work out to be 1. It'll be 1b times h. And if I'm trying to solve for the b variable, b is being multiplied by h. I want to undo that, so I'm going to divide by h, and I'll divide by h over here. And of course we find out that b is equal to 2a over h. So you can take, there's a triangle formula, you can take twice the area and divide by the height if you wanted to get the length of one of the bases, for example. Right? This second equation here I just made up. Let's say that I wanted to solve for b with this equation here. One of the challenges is it's part of a fraction. So you've got different possibilities. For example, you might put this over 1. You might make a proportion and cross multiply. That's something that would work. Or you might just say, you know what, I want to get this b out of the denominator. So I'm going to multiply the numerator by b. It's an equation, so the other side has to be multiplied by b as well. And keep in mind, if there's addition or subtraction, this whole side of the equation needs to be multiplied by b. So you're going to want to put that in parentheses, so the whole thing gets multiplied by b, or individually multiply both the c and the d by b. Okay? But in this case, I'm really trying to solve for b, so I'd like to write my equation in a way in which there's only one b written. And right now, we just have that single b. Okay, so once that's taken care of, we're actually pretty close to being done in this particular case. B is being multiplied by this value here of c minus d. Okay, so instead of distributing, let's just get rid of all of this that's being multiplied by b. I'm going to divide this side by c minus d, and I'll divide this side by c minus d as well. And of course, c minus d divided by itself is just 1, and we're left with just b. So, that's the sort of thing you can do. Multiply, divide, add, subtract. Make sure you're doing the same thing both sides of the equation and following basic rules, and it should work out pretty nicely. Now, there are some special cases. For example, what happens if you're trying to solve for a variable in which you have multiple of that variable showing up in the equation? Okay, so for example, let's say that I had something like 5 minus x. Let's do this. Something like 5 minus x all over x is equal to a, okay? And I wanted to solve for the x variable. Same kind of thing as before. You probably want to get it out of a fractional form. So whether or not that's multiplying the top and the bottom by x, whether or not that's putting that over 1 and cross-multiplying, you've got different types of possibilities, okay? Let's just multiply the top by x. Remember, it's this whole thing being multiplied by x. Multiply by x over here as well. The x's canceled, okay? I have 5 minus x is equal to ax, all right? Here's the key. If you're trying to solve for a variable that's repeating multiple times, you need to get every single term that's got that variable on the same side of the equation, okay? So you notice here I've got x's on the left and x's on the right. I'm going to add x to both sides, and that's going to end up giving me an equation that says that 5 is equal to ax plus x. And here's the trick. You can factor out x. So you can write that in a form in which there's only one x, because that's the idea. You're trying to isolate x, and you can't right now because there are 2 of them. Okay, so I'm going to factor this, and I'll rewrite this as 5 equals. I'm going to factor x out of both of these terms. I'm going to have a plus 1. When I divide x out of this, it just leaves me with a. When I divide that by x, it leaves me with 1. Okay, x is being multiplied by all of this, so I'll undo it by dividing by that. And it turns out that x is equal to, that of course is just 1. X ends up being equal to 5 over a plus 1. So whatever variable you're trying to isolate, get every instance of that over on one side of the equation, get everything that doesn't have that variable on the other side of the equation, factor it out, and in most cases you're going to be able to isolate that variable at that point. Hope that helps.